Okay, this is what I have so far for you guys. You can see this is where I've fixed now the velocities here to match what you guys should have fixed in the beginning of class. And you can see that I've got mass times gravity times height to get my potential energy, and then 1/2 times mass times velocity squared. So the only thing that I squared here was the 28 to get this answer. And then I added them together to get the total mechanical energy. You might also notice that this number is a little bit smaller than this one, which makes sense because some of that mechanical energy is going to get lost to heat, to thermal energy. And thermal energy is non-mechanical, so it's not going to be included in this mechanical calculation. Okay? So the next thing that you'll do is calculate these other 4, and you can check your answers with one of the instructors in class today. And then the final thing that I'd like for you guys to do is on the back page. Here we are. I want you to look up some real roller coasters. So you can check out like Six Flags or Worlds of Fun right here in Kansas City. Any of them that you want, and you're going to write down the name of that roller coaster. So right here, I want to know the name and the location. So like maybe you decide to do the Mamba, which is at Worlds of Fun. Okay, and then what you'll end up doing is actually looking up information about the Mamba. And I'm looking some up right now. You want to find out, and you can find all of this information on Wikipedia, that's fine, or you can actually go to like the website for Worlds of Fun, and that will work. And so we want to know for the Mamba, what is its tallest height and what is its fastest maximum speed. So its height, if you actually look up on Wikipedia, is 205 feet, which is equal to 62 meters. So for example, what I put here for my roller coaster, Mamba, tallest point is 62 meters. And then I want to know its maximum speed. According to this, it is 75 miles per hour, which is 121 kilometers per hour. I'm going to go ahead and just type in 121 kilometers per hour to meters per second, because we are working with meters per second. It is 33.6 meters per second, and all I did was just type that into Google. Okay, that's meters per second. Got to use our SI units. So then what you're going to be doing down here is the same thing that we did before. We're not going to be doing a total mechanical energy for these because your maximum potential energy is not going to be at the same place as your maximum kinetic energy, so it really wouldn't make sense to add those together. So down here, Mamba. And then for my maximum potential energy, we're going to go ahead and still use this mass, the 1230 kilograms. So this is going to be PEG is equal to mgh. Okay, so that is going to be 1230 kilograms times 9.8 meters per second squared times the height, which is 62 meters. Okay, plug that into my calculator real quick. 1230 times 9.8 times 62, and I get 747,348 joules. Okay, and then for maximum speed, I'm going to use the formula KE equals 1/2 mv squared. So that is going to be 1/2 times 1230 kilograms times my velocity, which is 33.6 meters per second. That is the number that we're squaring. So I can type in 0.5 times 1230 times 33.6 squared. You don't actually have to put it in parentheses here because these calculators should do PEMDAS, order of operations, but just to be sure, we can make sure by putting it in parentheses. Yep, got the exact same thing. So that is equal to 694,310.4 joules. Or we could just round that off to 694,310 joules and call it good. Either one is fine. If you get an answer where there's lots and lots of decimal places, feel free to round it off to that closest whole number, so just not have any decimals. So I can just go ahead and round it off like that, and I'll be good. Okay, so that's my example. You can't use the Mamba. You've got to come up with 3 others, all right? Not just 2, but 3. You don't get to use my example, okay? All right, that's it. See you guys. Hopefully I will see you on Wednesday.